Hello, hello.
Yes, sir.
Hello,
Yes,
Uh,
so
good evening, everyone.
Good evening, ma'am.
good evening,
Okay,
ma'am.
how are you all? How was the exam?
Exam was good, ma'am.
It was good. Was it
Ma'am, actually,
easy?
I want
How
to
was it?
know that will be solution video of the quiz too?
Solution video. No.
Okay,
If you have any doubts with the quiz, you can just ask the doubt. That's it. There would be no solution videos or anything.
okay. No, actually, I was having in doubt in one question in quiz.
Hmm.
It was a question in which we had to find the value of R.
Find
We
the
were given.
value.
I'll find the question and tell you.
Sure. Okay, what about the others? Was it easy, tough? How was it? Moderate, average?
Ma'am, easy.
Yeah, it was easy, right? Okay then.
Ma'am,
So
Uh,
in term syllabus, week 1 to week 12, right?
yeah, for end term, it's week 1 to 12, the whole
Okay, ma'am.
week. Okay, so
I actually had a doubt regarding the extra activity 3.
what is
Can I
it?
like clarify? In the grading criteria, it's like written of it's basically we have to make an analysis according to the measure of central tendency and dispersion as well. So in the measures of central tendency, and they're asking for the visualization as well. So like plotting the graph. So
Hmm.
what does that mean? Like uh, plotting the graph for mode, median, and mean, or like what does it mean?
Okay, just let me find out measure of central tendency. Because
In the description as well, it's written as
yeah,
in
I'm just reading the description.
yeah,
Identify
okay.
the following from your data set and also give the reason behind measure of central tendency, measure of dispersion. So in measure of central tendency, you have the three measure of central tendency, right? You have mean, median, mode, correct?
Yeah.
So I guess like the three of them, I think so.
So like what type of graph? Like how? Like what graph
Measure
do
of
we like
central
plot?
tendency. See, for the mean, you can't have a graph, but for mode, you can have a graph, right? Or you can show the um like the batsman who have scored the highest or something, right? So mode is like showing the highest frequency of some category, and median is like median.
So like can we like we should plot this for every variable, right? Like suppose if I have like 5 variables,
Yeah, so
let's say
what all
gender.
things you are identifying, for that only you have to make the visual, like make the graph, or like you have to yeah, for all for whatever category you are identifying the measure of central tendency or measure of dispersion, just for that only you have to make the graph or anything.
Yeah, so
Okay.
like only for mode, median, how do we do it?
Yeah, so for mean, how can you make a graph? For mean, you can't have a for average.
No, I mean
Like, yeah,
median.
you can
Median.
have a mean, like if you're comparing two categories or something, you can compare it, compare the means and all. You can have anything. Yeah, so it basically depends upon your data set, what you want to visualize. Or by visualization, in the sense, what you're visualizing. If you are, I think the output or something, or you are predicting something, or you're making out from, you're describing your data or something. So through visualization only you are going to describe your data, correct? So I guess for that only they are telling you to identify
So
that
like for
by visual.
example, like let's say I have like a variable called gender, so like male and female. Here, according to my data set, female has more it has the highest frequency. So like the mode is obviously female here. So then by plotting the patro graph, like it would have like a higher like the height of the bar would be high. So like that I'll
Yes,
show
any
the
kind of
mode.
you can show anything.
Okay. All right. Thank you.
Ma'am, I have doubts from these two questions. When can I resolve this?
That I will take after completing this week 9. Let me just complete week 9, then we will discuss it. Fine?
Okay.
Yeah.
Ma'am, shall we discuss the activity question in this session?
No. First, I
Oh,
will just go. This is a solve with us. First, I have some questions. You have to do that questions. And on Friday,
okay.
we have the doubt session. So on that day, we will discuss your activity questions and assignment questions. Okay?
Okay, ma'am.
Okay. Okay then. So have you guys gone through the videos lectures of week 9? Anyone?
Yes, ma'am.
Yeah,
Yes?
till 9.3.
Till 9.3. Okay. What about others?
Yeah, ma'am.
What? Sorry, like have you gone through the lectures of week 9?
Yes, ma'am, till 9.5.
Okay. Okay then.
I'm 9.6.
Good. That's nice. Okay. So let's start with the session, shall we?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the same thing. I will just going through, like I will give you the summary, the overall summary. Okay. Then we will solve some questions. That's it. I won't go deep because the lectures are already there. So I will just briefly tell you about the topics. Fine. Okay.
Okay, ma'am.
Okay then. So in week 9, we are going to talk about random variable, a discrete random variable, then its PMF and serial. Okay. So now, first of all, what is a random variable? What is a random variable? Anyone? A real valued function defined on the
Sample space.
correct, defined on the sample space. Okay. So basically, if I want, let's suppose I'm I'm tossing a coin. So let's suppose I'm tossing it twice. So I want to know the number of heads in the two tosses. Okay. So I'm denoting this event with a variable X. So this is my random variable. Okay. So this is a real valued function defined on some sample space. So that is my random variable. Okay. So let's suppose I am rolling a dice twice. Okay. Then
Excuse me, are you
if
doing
I
a summary
want to
before the
know,
solving?
sorry,
Are you doing a summary of the topic before the solving?
yeah, I'm just briefing out the topics. That's all. Okay. So now I'm rolling a dice twice. Now I want to know the outcome that the sum is 7. So I'm denoting this event with some random variable, which is X. So what is a random variable? Random variable is a real valued function defined on the sample space. Is it clear? What is a random variable? Right? Now, our random variable is of two types. One is discrete random variable, and the other one is continuous random variable. Okay, so what is the difference between a discrete and a continuous?
In
Anyone?
discrete variable, we can count. the outcomes, while continuous is a measurement of the sample
Yeah.
space.
Correct. So in discrete, we can count. Sorry, you were saying something?
No, ma'am, I'm saying that it takes whole number.
It's not necessary. We can have integers, we can have decimal as well. So we can have any number. So discrete, the main thing is in discrete, if it is a countable, then it's a discrete. If it is not countable, then it's a continuous random variable. Okay?
Okay, ma'am.
Now, so let's suppose, so what are the examples like what are the example of discrete? Like number of pages, we can say.
Ma'am,
Or
how come the time will come under the continuous random variable?
what time?
Time,
Like
generally measurement of time.
measurement of time is continuous, right? No?
Yes, yes.
Yeah, it's a continuous. So see,
How?
in this,
Yeah.
I'm
Yeah.
just
It's
talking about that only. So in discrete, we basically count, and in continuous, if it has measurements, okay. So measurements in the sense like it's kilogram or hours, meter, minutes, anything. Like if we have measurements, we say it is a continuous variable. Okay.
Excuse me,
Eh,
ma'am.
Yes.
I just want to confirm random variable that the x is there. X is any number we assign to a particular event.
Sorry. Once again.
I'm just trying to confirm one thing, that the random variable that is x that is there. X is any number that we assign to a particular event in the sample space. Or
No.
hello,
X is a number.
means yeah. Please confirm if I'm right. Means x that is there in the random variable. X is any number that we assign to any event in the sample space.
Huh. Like
Means
it's an event. Yeah. Correct.
means I'm trying to say that we can means it is any number, or we have to like the number of counts, number of something is there has to be a constant.
There has to be.
Means that x the number we assign, that number should be means should the number should always be count of something, or some measurement, or we can assign any number, or there is some constant to what we can assign,
It
some range.
depends upon what are the events. So let's suppose if I'm tossing a coin, okay. So what are my two events? Head and tail, correct?
Yes.
So if I'm tossing it twice, so that means I will be having. So if I want to know, so X is my event that I'm getting number of heads, correct? So what are my numbers of X? Like what are the range of X? It can be 0, it can be 1, it can be 2, correct?
Yes.
I can have 0 heads, I can have 1 head, and I can have 2 heads. So basically, what is my X? So I'm denoting an event with my numbers. It's a real value function, correct? So it can't be any number. It should depends upon the event.
So basically,
Fish.
x is any event, and depending upon that event, the value of
Hmm.
x is the number of possible outcomes.
Correct.
Means yeah, suppose if x was the event that I get a heart out of a deck of 52 cards, the possible values of x will be 0 to 13.
So once again, what?
Means just for confirmation, if I suppose I define x, that is the number of hearts I can get from a pack of shuffled cards. So the value of x will range from 0 till 13. Am I right?
Correct.
Okay. And that till this I understood the discrete and continuous part. Could you please explain? That time I was disconnected. The random
Discrete and
variable.
continuous, a discrete variable are variable which are countable, and continuous which are not countable.
Okay.
Okay, which you cannot count. So in countable in the sense number of pages, number of language, or number of books, or anything. Like
Okay.
you can count it, right? And continuous, if there are measurements like kilogram, hour, minute, temperature, or anything, if there are measurements, then we say it is a continuous variable.
Ma'am, can you give me an example for discrete random variable which have decimal points as
So, okay,
values?
let's suppose, what should I say? Um,
Number of students in the class?
Ma'am,
number
can I
of
tell?
You're asking about decimal thing, you are.
Yeah.
Acha.
Discrete random variable which have decimal values as
So let's suppose there is something like like there is one category. Okay, right now I'm not having any particular category in my mind. So let's suppose I'm having a category and it has some particular values like 4.5, 5.0, and 6.4. That's it. There are particular values.
okay.
If there is only particular value, some distinct values, then we say this is a discrete. Okay, but if you don't have any distinct values, let's suppose I am having like area of a field. Okay, so area of a field is like 6500.05, 6500.06, then 6500.80. Then I have 7, let's suppose 6600.01. So these are not distinct, right? So I'm having like I have 6500.05. So these are my area, that means square feet, let's suppose. So this is my continuous. Understood?
When the decimal ones
So
are
if I,
going to be continuous,
sorry,
the decimal ones are going to be included in continuous.
no, it's not necessary. It depends upon the situations. So in this, I have a distinct value. So this is a distinct. In this, I don't have distinct values. These are my measurements. So if I'm asking about the area of a land, so I would be telling them in interval that my area of a land is going from 6,000 square feet to 7, let's suppose 7,000 square feet, like that. Okay, this is some category. Let's suppose like some number or something number. Okay, I'm not having any.
Okay, ma'am. We'll discuss
Yeah.
this later. Thank you.
Yeah, so this is a discrete and a continuous. If it's distinct, that's a discrete. If it's a measurement, then it's a continuous. Okay.
Yeah, ma'am. Understood.
Yeah.
Ma'am.
Okay.
Could you scroll up once?
Ma'am,
Yes.
ma'am, if measurement is not like given in decimal and it is given in a whole number, then
Then
And could
also
you
it's a
please
continuous.
once scroll up the number 1 point?
Ma'am.
Okay, sure. You have any doubt?
Excuse me, ma'am.
Ma'am,
Yes.
let's say I have taken 1.5 medicine. So this is also discrete variable. One
Yeah,
and
one and
half
a half,
or
that's it. Yeah, 1.5. It's a discrete.
okay, ma'am.
Okay,
I'm
shall we
just
continue?
hello.
Yes.
And this actually random variable, the definition given is real valued function means what does it take and what does it give, means what input does it take and what output does it give.
What input and output?
Hello.
Yes.
Means just asking that random variable is a real valued function. What input does it take and what does it give to us, the output?
I think the input is from sample space and output is the value we are assigning. Is it so, ma'am?
Yeah. So what is, see, I am denoting some variable on the basis of what? On the basis of the sample space, right? So if I'm tossing a coin, so I would be denoting a random variable on the basis of sample space only, not on the basis of some other thing, right? So I'm having
Yes.
some sample space. On that basis, I have to. So if I like in particular, I want to know about something. If I want to know about a particular numerical quantity, I denote it by a random variable, which is x. So basically, this is from a sample space, a function which I am getting from a sample space. Okay. Okay. Now can we continue?
Yes, ma'am.
Okay. Now we have, so random variable were of two types, discrete and continuous. Then we will be talking about discrete random variable. So in discrete random variable, we have PMF. Okay. So earlier we were denoting an event X. Okay, an event X, and with that event X, we were having some values, right? Like suppose X1, X2, X3, we were having some values, right? So with these values, we have some probabilities as well, which is denoted by Px1, Px2, Px3, and so on. Okay, so this probabilities are known as PM, which is known as probability mass function. So if we are finding out the probability for a discrete random variable, we call it as PMF. Fine? Is it fine?
Yes,
Right?
ma'am.
Now,
Yes,
we
ma'am.
have two properties for the PMF. So the first property is that my probabilities should be greater than 0.
What is PMF?
PMF is probability mass function. It is the probabilities which are for the discrete random variable. Okay? Okay. So there are two properties. The first property is the probability that each of these probabilities should be greater than equal to 0. And second, the sum of all the probabilities where I is going from 1 to infinite should be equal to 1. Is it fine? So these are the two probabilities. If these properties are followed, then it's a valid PMF. Got it? Is it
Yes,
fine?
ma'am.
Okay. So tell
Yes, ma'am.
me if I have, okay, X is a random variable. Okay. It has values 1, 2, 3, 4, and 5. Then I have the probabilities as 0 0.4, 0 0.1, 0 0.2, 0 0.1, and 0 0.3. Can you tell me if it is a valid PMF or not?
No, ma'am.
No, ma'am.
Sum is not
No.
greater than
No.
sum is
Sum
greater
is
than 1.
greater than 1.
The
Sum
sum
is,
of all the functions should be 1.
it should be 1. It is not coming
No,
out to
no,
be 1. So
no.
if I had one, let's suppose if I had this, is this a correct PMF?
No. No negative values.
Yeah, because I have one negative value. So this is not a correct PMF. So just remember these two properties. The first property is all the probabilities should be greater than equal to 0, and the sum of probabilities should be equal to 1. Then only we can define it as a valid PMF. Fine?
Yes, ma'am.
Okay. Then we have the graph of PMF. Okay. So how do we make a graph of a PMF? So if I'm having a values of X, like let's suppose I'm having X as 0, 1, and 2, and the probabilities are like 0 0.25, 0 0.5, and 0 0.25. So if I'm going to make a graph, okay, so this is my 0, 1, and 2. So 0 0.2, 0 0.4, 0 0.6. So first is 0 0.25. So this will be somewhat here. Then for 1, it is 0 0.5, this side, and for 2 as well here. So the graph of a PMF is basically like a bar graph. Okay, and all the bars are showing these are my probabilities, Px1, Px2, and Px3. Right? So we can have different type of graph. So this is like a like a symmetric graph, correct? We can have a uniform graph as well. We can have skewed graph as well. Fine? Is it fine?
Ma'am, I do not understand these graphs yet.
What the skewed graph means?
Skewed graph in the sense if I'm having a graph like this, like this is a right skewed, correct?
So basically, it depends upon the order of the outcomes.
See, it depends upon the probabilities. So like here I'm having 0.25, then 0.5 and 0.25. So this is like coming out to be like a symmetric graph. I can have a skewed graph. I can have a uniform graph as well, in which I'm having, when I can get a uniform graph, if I'm tossing a coin, okay, head and tail. So what are the probabilities of getting a head? 0.5. And what are the probabilities of getting a tail? 0.5, correct? So this is a uniform distribution. You got my point? Like getting yeah, so that this is a uniform, this is symmetric, this is skewed. So we can have different type of graphs. Understood? Graph is
Yes,
just
ma'am.
simple. Like we are just plotting the probabilities. That's it.
I
Okay.
mean,
Then we have
skewed graph, whether we need to arrange the variables according to the probabilities
no.
or
No,
by
we don't have to arrange
we need
anything.
not. Okay, by the graph
Yeah.
itself will be either in ascending order or
Excuse me,
descending order. Okay. Okay.
ma'am, please repeat that. What is symmetric function and
So, ma'am, this is the symmetric graph.
the previous topic?
Once again, what?
The symmetric and uniform skewed graph. Please repeat this topic.
Okay. So if I'm having this type of graph in which, like, what is symmetric? Symmetric in the sense, like we are having this type
Yes,
of
in the
graph is
midway
basically
and the left.
a symmetric graph, right? If I'm
Okay,
having
ma'am.
this type of graph, this is basically a skewed graph, correct? And what is a uniform? That all the values, all the probabilities are same. So I'm having one constant line. That's it.
Yes,
So this
ma'am.
is a uniform.
Understood.
Yeah, that's a symmetric, and this is skewed. Got it?
Yes, ma'am. Got it.
Okay. Then anything else?
Ma'am,
Shall we move forward?
Can I ask the syllabus for the end term?
It's week 1 to 12. Fine.
When you come for the skewed graph, is both the direction it will be the same, or it may have any difference?
Sorry, what direction in the sense?
I mean, it is actually from left to right. It's actually coming. So
Yeah, we can
if it's
have
in
both
the
sides, right? We can
yeah,
have
so
a graph like this as well, in which this is going like this.
okay. Thank
Yeah,
you.
we can have left skewed, we can have right skewed.
Thank you.
Okay. Now the last topic is CDF. What is the CDF?
Week 1 to 4, week 1 to 8, week 1 to 12 for syllabus for NTEM.
Yes.
Okay, thank you.
Now we have cumulative distribution function. What is the cumulative distribution function in the sense?
The graph should be in any of these three types only, yeah? Is that so?
Yeah,
It must be. It must
uniform.
be. It must be. Oh.
Yeah, we can have like this. It is not necessary.
Shall we have irregular shapes?
Irregular shapes, yeah. We can
yeah,
say
yeah, we
anything.
can. Okay.
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 Anything else? Shall I move forward then to the last topic?
Yes, ma'am.
Okay. Now we have CDF. CDF is cumulative distribution function. So earlier we were finding out the probabilities for some particular value, right? So probability of xi in the sense like probability of x equals to 0 or probability x equals to 1 or probability x equals to 2, correct? If I have to find out probability of x less than equal to 1 or probability of x greater than equal to 2, okay? If I have to find out this thing, we call it as a cumulative distribution function. So if I say probability of x less than equal to 1, it contains what? Probabilities of x equals to 0 plus probability of x equals to 1. So we are adding both of the probabilities. It is a cumulative probabilities. Similarly, probability of x greater than equal to 2. Let's suppose I'm having the xi values from 0 to 4. Okay, so probabilities of x greater than equal to 2. This will include what? Probabilities of x equals to
2, 3, and 4.
2, 3, and 4. Correct. So this will be the cumulative of 2, 3, and 4. Fine. Okay. Now, so
So, ma'am,
my CD.
these, this is a little bit confusing up there.
Can you
These
please
individual
repeat it?
probabilities are equal to 1, and then we are adding them.
Individual probabilities are equal. Where individual probabilities?
So I don't understand this cumulative distribution function.
Okay. See, earlier
I
we
could
were
not
just
get the CDF.
okay, let me just repeat it once again. So earlier we were having variable x with particular values, correct? So I'm having x values like 0, 1, and 2. With that, we had the probabilities. Fine, right? So this was probability of x1, probability of x2, and probability of x3, correct? So what is probability of x1? Probability of x1 is basically probability x equals to 0. Fine?
Yes.
Yes. Okay. Now, this is like for some distinct value. If I have to find out probability x less than equal to 1, okay, probability x less than equal to 1. So this is what? Probability of x equals to 0 plus probability of x equals to 1. Yes or no?
Is it something like union? Union of probabilities for x is equal to 0 and x is equal to 1?
Yeah. No, we are calculating the probability. Okay, probability of x less than equal to 1. What does this mean?
Yeah,
That
it's
what are the value of the probability that x
it's
equals x
ze-
taking values less
pro-
than equal to 1,
yeah, it's
right?
0 and 1.
0 and 1 other values, right? So what are the
Okay.
probability that x equals to 0 plus probability of x equals to 1? Is it fine?
Yes, ma'am. Yes.
Yes?
Now, could you
Me,
please
Anju,
just
and
go to the
everyone?
previous point? Was I will take a screenshot. The previous point 5 and 4. I will just take a screenshot.
I'll just like I will upload this PDF, don't worry. Okay. Similarly, probability, if I have to calculate the probability x greater than equal to 2, that means I have to calculate the value of probabilities for values of x greater than 2. So it will include if I'm having values of x as 0 to 4, okay, then it will include 2, 3, and 4, correct?
Yes.
Now is it
Got
fine?
it. Yes, ma'am. Got it.
So what we are calculating? We are calculating the cumulative probabilities, right? So my CDF is denoted by FA, where my FA is equals to probability of x less than equal to A. Okay. So I will denote my CDF with capital F bracket A, which is equal to probability of x less than equal to A. So if I'm taking this example, probability of x less than equal to 1. So if you compare this, my A is what? A is what? 1. So I can denote this as F bracket 1. Okay. Till here, is it fine?
F means function. Is it function or what it denotes? F.
Function. F is just a function.
Okay.
Okay. Like we denote the PDF by small f, correct? So we denote this, like if we denote the PMF with small f, we denote with CDF with capital F. Okay. Okay, this is not enough. Okay, you will just learn this thing later. Just remember this thing. The CDF is denoted with capital F. Okay.
Okay, ma'am.
And for what value you are calculating, you have to write that in the bracket. Okay.
So, ma'am, earlier we learned about PMF. So this cumulative distribution function is going to be the sum of individual PMFs.
Correct.
Okay.
Okay. I'll just take an example. Okay. Now, X is taking values 1, 2, 3, and 4. And these are my probabilities. Okay. So for 1, it is 1 by 4. For 2, it is 1 by 2. For 3, it is 1 by 8. And by 4, it is 1 by 8. Okay. This is my PMF. Now I need to calculate the CDF. Okay. So so what is my CDF? CDF is basically probability of X less than equal to some value, right? Okay. Now here I will be taking the range of values. Okay. So first of all, okay, so the starting thing is, okay, let me make a graph. We have 1, we have 2, 3, and 4. Now, first comes my value A is less than 1. So if you see here, this is what probability at, like this is probability at 1. So less than 1 will be equal to 0 only, all the probabilities.
Yes.
Right? So for this, if you see here, these all my probabilities will be 0. Correct?
Yes.
Okay. Now, we have my value of A is going from 1 to less than 2. If you see here from the graph. Now I have to take the values. So at 1, it is 1 by 4, right? So this is coming out to be 1 by 4. Let's suppose this is 1 by 4. So this is 1 by 4. Now till 2, so at 1.2, so this is like probability of X equals to 1 is 1 by 4. Now probability of X less than equal to 1.1. So this will be what? Probability of X equals to 1 plus probability of X equals to 0.1. Correct? Yes or no, right? Now, this, we know probability of X equals to 1 is 1 by 4. And probability of X equals to 0.1 is 0 only. Right?
Yes.
Right? So this is what? So probability of X less than 1.1 is 1.4, right? So it's 1 by 4. So this is also 1.1 by 4, 1 by 4, 1 by 4 till 2, it will be 1 by 4, right?
Excuse me, ma'am.
Yes.
X less than 1.1 probability. How did we do X equal to 1 plus X equal to 0.1? That probability, that part I couldn't get.
Okay. See, now this is probability of X equals to 1. So this is 1 by 4. Now this part is what? Probability of X equals to 1.1, correct? So now I have to calculate this range. So this is coming out to be probability of X less than equal to 1.1, right? Now I can write this as probability of X equals to 1 plus probability of X equals to 0.1, right? So 1 plus 0.1 is 1.1 only, correct? Yes or no?
Yes.
Right? Now,
Yes.
probability of X equals to 1 is 1 by 4. And probability of x equals to 0.1 is 0. So if we add this, we are getting 1 by 4, right? So probability of x equals, so from here to this is 1 by 4. Similarly, if I go like this, I will get 1 by 4, constant value, correct? From 1 to 2, right or wrong? Yes or no? Yes? Did you get the point?
Yes.
Is there any confusion?
Excuse me, ma'am. Hello.
Yes.
Sorry, ma'am. Actually, before that, they were explaining example like suppose probability of x less than equal to 2, that is equal to p of 0 plus p of 1 plus p of 2, like that. So, with respect to that, I was getting confused how p equal to p x equal to 1.1. How can you find like p of 0 plus p of 1 plus p of 1.1? I am mixing up, but
What?
I'm actually previously you gave an example like for example probability of p x less than equal to 2. So that in that we do p x equal to 0 plus p x equal to 1 plus p x equal to 2. With respect to that, I was getting confused here. Like here we have to do p x less than equal to 1.1. So what do we have to sum here? Like p of 0 plus p of 1 plus p of 1.1, like that. I was getting confused.
Okay.
Any
Please, could I
example,
put my
simpler
doubt
one that
clearly?
What you were saying?
any other example other than this, a simpler one will help clear the confusion.
Okay, we can take one more example. I'm
Ma'am,
having,
were you
for this,
able
I'm
to
having
get my doubt?
0 and 1. Okay. And I'm having the probabilities as well. Like this is 1 by 2 and this is 1 by 2. Fine. Now I need to make a CDF. Now for fx, so for f, like this is a. I will be having, so first of all, a less than 0. What will be a less than 0? It will be 0 only, because at 0 point I am having a probability and at 1 I am having probability. So other than that, if my x takes any value, it will be 0, right? Okay. X is taking 0 and 1, and probabilities associated with are 1 by 2 and 1 by 2. Now I have to make a CDF. Okay. Now, if you see here, so probability x equals to 0 is 1 by 2 and probability of x equals to 1 is 1 by 2. So if I take values, probability of x equals to any values other than I equals to, if it's like, it's not equal to 0 and 1, this will be 0, correct? Yes or no?
Yes.
Yes, ma'am.
Okay. Now, my CDF, how will I? So if I plot a graph here, 0 and 1. So what is my FCDF? CDF is basically my cumulative distribution, right? So first of all, I will start from here. From here, I will start, correct?
Yes.
Let's change the number. 1, 2. Okay. This is 1 and this is 2. Now, I will start from here So it's less than 1. This is 0 only. Correct?
Yes, ma'am.
Yes, ma'am.
Okay. So from here, so if my value of A is less than 1, it is coming out to be 0. So from this till 1, it is 0. Now at 1, it have a jump. It jumps to some value, which is 1 by 2. Correct?
Yes.
Yes. Okay. Now, from this to here, what will be my value? So now 1 by 2 is what? My value of A is between 1 to 2, right? So 1 by 2 is this value. Correct? Yes or no?
Yes, ma'am.
How come, ma'am, if probability will be 0 if it is not 1 and
Okay.
2, right? So how come it be continuous from 1 to 2?
Okay. Now this is probability of x less than 2, correct? So this is what considering my probability x equals to 1, right?
Yes.
So in this, so this probability is 1 by 2 only.
Yes.
So all of the probabilities. So from 1, so less than 2, all of my numbers in between this, it will be 1 by 2 only, right? It will be a constant value.
But in that function you told, no, if x takes the values other than 1 and 2, the probability
Okay.
will be 0.
Okay, let's take this thing. This is like 1.5, right?
Yeah.
Yeah.
If it is
Okay.
1.5, we don't have any probabilities related to 1.5, right? We have
Correct. Now, if I have to find out from this to this, what will it be? It will be probability of x less than 1.5, less than equal to 1.5, right?
yeah.
Now, can I write this as probability of x equals to 1 plus probability of x equals to 0.5?
Yes, yes.
Okay.
Yes, ma'am.
Okay. Now, what is probability of x equals to 1?
Half.
And what is probability of x equals to 0.5?
It's 0.
So it's turn out to be 1 by 2. So my range from 1 to 1.5 is 1 by 2. Similarly, from this to this side is also 1 by 2. It will be a constant. Yes or no?
But
Yes.
this violates the property of probability mass function.
Like what? Which function?
If suppose the probability of you told 1.5 is equal to half.
Probability of 1.5 is not half. We are finding out probability of x less than equal to 1.5, not equal to 1.5. I need to find out from 1 to 2, that's it. So if I have to find out values from 1 to 2, so I'm not including 2. So this will be probability of x less than 2. So this will include what? Probability of x equals to 1 only, which is 1 by 2. So all my values less than 2 will be equal to 1 by 2. Yes? In a simple manner, if you say yes or no.
Yes.
That if that is so, mm,
What's your
Basically,
doubt?
it lies in the interval between 0 to 2, right?
Huh. You can say my value of a is from 1 to 1 like equal to 1 and less than 2. Now at 2, it will jump again. So at 2, it will be what? It will be 1 by 2 plus 1 by 2, which is 1. So now after 2, it will be constant, which is 1.
Got it, ma'am. Yeah.
But again, when you say after 2, it means it will be 2 to 3 or 2 to infinity.
2 to infinity.
How come, ma'am? After 2, it must be 0 only, right? Probability after 2. That's what the random variable function, no?
Greater than 2. I'm not saying equal to anything. I'm saying greater than equal to. I'm not saying anything equal to. Greater than, less than, greater than. I'm just talking about greater than, less than. I'm not talking particularly about some particular value. I'm talking about greater than, equal to, less than, equal to. That's it.
Ma'am, if the probability after 2 will be 1, then why do we call it a random? Because like
Yeah.
if it always come 1, then it should not be called as random, ma'am.
Yeah,
Random
yeah.
variable.
Yes.
What? Can like say it once again?
Ma'am, probability is equal to 1 means that it is certain that it is going to happen, right?
Ma'am, so after 2, it will have to 0 now. What's
After
right?
2,
Yeah,
you are
after
saying
2,
the
actually,
probability will be 1.
You have mentioned also.
because it violates the second property of probability mass function. Because the second property is telling that the summation
But
of
this
all
is
the
a
probabilities is
CDF,
equal
right?
to 1.
This is a CDF, cumulative distribution function. I'm calculating
Cumulative
cumulative.
And ma'am,
distribution.
I not equal to 0, 1 or not equal to 1,
Oh,
comma 2.
I'm not talking about a particular probability. I'm talking about cumulative. Got the point?
Yeah, that's the reason she added 1 and 0.5, if you remember.
You're getting the point? I'm not talking about a particular probability. I'm talking about cumulative distribution function. I'm talking about
yeah, quite
cumulative probabilities. Now you got the point?
Yes, ma'am.
Yeah, okay. So CDF is what? I'm just adding the probabilities. So first of all, from 0 to 1, what are the cumulative from 0 to 1? Then from 1 to 2, then from 2 to infinite, like that. So I'm talking about the cumulative probabilities, not a particular probability. Okay, so now you got the point. So from 0 to 1, this is 0. Then at 1, it jumps. Okay, at 1 by 2. Then from here till 2, it will be constant. It will be taking 1 by 2 only. Then at 2, it will have a next jump, which is at 1. Right? Now from 2, it will be constant again. Like that. So this is a cumulative thing. I'm not talking for a particular probability. I'm talking about a cumulative function.
If the probability of the first you put values here 1.5. Instead, if we put 1, the total of this probability is 1, and the probability of 1 to 2 is another 1, and 2 to 3 is another 1. Then in that case, what happens?
Do you remember
Like you
the
have taken
property, like the probability, each of the probabilities should be equal to 1?
equal to 1.
So how can you
Okay.
have probabilities like 1?
So the maximum value for this cumulative function should be 1 only. So we will not be having more than that.
Correct.
Oh, okay. Okay.
Okay. Now you got the point how you calculate.
This is not the addition. This is the addition, but ultimately, in the end, it is going to be 1.
Correct.
Okay.
Fine. Now you got the point for CDF.
For me, it is clear, ma'am. Thank you.
What about others?
I think I need to go through the slides, the session, recorded session.
Yeah, you can just go through it once again.
Okay.
Okay. Okay. So the CDF part is, so this was the last part. So theory part is clear to everyone?
Yes, ma'am.
Okay. So shall we
Yes,
move
ma'am.
forward to the questions then?
Yes, ma'am.
I mean, is it possible to give a recap if you have time, or should I go through the YouTube channel?
Sorry?
Is it possible to give a recap because I joined a bit late, almost around 6:30? Can you give a recap, or can I watch the video?
Let's solve the questions, then I'll just tell you like what all things are
Okay.
there.
Yeah, fine. Thank you.
Good. Okay. Now, the first question. Range of a random variable x is a set of all possible values that x can take. So what is my here? Here my x is a random variable which is taking all the possible values. Okay. So what is the range? Range is basically all the possible values that x can take. So before we had, if I'm tossing a coin, I'm having head and tail. Okay. Now, what is x? X is the number, if I'm tossing it twice, so the number of heads I'm getting, which is 0, 1, and 2. So what is the range of x? It is from 0 to 0, 1, and 2. So this is my range. These are the values that x can take, right? So now
Ma'am,
the
I can't
condition
understand.
is,
Can you repeat once again, ma'am?
here in this, we are talking about range. What is the range? All the possible values that x can take. So if I'm tossing a coin twice, okay, and x is the event that I am getting the number of heads. Okay, so what are the values that x can take? It can take 0, 1, and 2. So what is my range? 0, 1, and 2. Correct?
Ma'am, how can it take 0?
Ma'am,
0
one
heads.
String of
If
no
you
head.
didn't get any head. Okay, so now the
No,
question
it's
is,
written.
let a random variable y be defined as the number of tosses until first head comes on tossing a coin. Okay, so what is a y? Y is number of tosses until first head comes. Then what will be the range of y?
C, ma'am. Option
Ma'am,
C.
it's
1, 2, 3.
option D.
No, C.
C.
Yes, ma'am.
Okay, so I was actually confused. I thought you were discussing about Y.
No, no, no.
Yeah.
Okay, so this, okay, so the answer is 1,
Why
2, 3.
not D, ma'am?
Y is number of tosses. What do you mean by 0? You're not even tossing a coin. So if you're not tossing a coin, how
Yes,
can
ma'am.
you get a head?
Yes, ma'am. Before tossing itself, we are just not considering any event. It's an empty, like a null set.
So y is
Just
already not there, na?
considering it.
What is y? Y is number of tosses until the first head comes. First you have to
Okay,
toss, then only
okay.
you can have the head, right?
Yes, ma'am. I got it.
Now, consider the following. Number of spelling mistakes in a report, time taken by a person to write an exam, and weight of a person. Which of them is a discrete random variable?
Number of the spelling
Option A, ma'am.
mistakes.
Number of spelling mistakes
Number
in a
of this
report.
A.
Yeah, this will be
Option
A. Why
Yes,
not
ma'am.
B and C?
So, all
Ma'am,
measurements.
It's
because
measurement.
exam has a limited time, ma'am. 3 hours means 3 hours, 1.5 hours. And a weight of a person is a discrete value like 52 kgs, 80, like that.
Ma'am, B and C are measurement.
Correct. Now, let x be a random variable and takes value 0 to infinite. By applying the properties of PMF, find whether this is a PMF. Solve it and tell me.
Ma'am, I've sent a doubt in the chat. Can you clarify that?
That. Okay. Till then, everybody please solve the question. What is the activity 9.1?
Yes, no.
Okay, let me just finish this. So on Friday we are having doubt session. So if I have time, I will do it today. Otherwise, I will do it on Friday. Okay?
Okay, ma'am.
Hmm.
How can we find the summation of the probabilities?
It's
Ma'am?
not a PMF.
It satisfies the first property, but I don't know how to calculate the summation of the probabilities.
Okay. What about the others? Are you able to solve it?
No, ma'am.
Okay.
Just we have to substitute the values of x, right?
Ma'am, it's actually a GP, right?
Hmm.
Yeah, I've solved it.
That's all.
Yeah, it's 1.
Yeah, it's fine. Okay. So I'll just solve it. So first of all, what are first property? So first property is all my probabilities should be greater than equal to 0. So if you see here, all my probabilities are greater than equal to 0 only, right? Now the second property is my sum of all the probabilities should be equal to 1, correct? Now, summation of 5 by 6, 1 by 6 raised to the power x. And my value of x is going from 0 to infinite, correct? Now, this thing, I can write it as 5 by 6, 1 by 6 raised to the power 0 plus 5 by 6 into 1 by 6 raised to the power 1 plus 5 by 6 into 1 by 6 raised to the power 2 and so on, correct?
Yes,
Yes?
ma'am.
Yes, ma'am.
Okay. Now, from this, I can take 5 by 6 as common. Now, what is left?
Yes, ma'am.
1 by 6 raised to the power 0 is 1 plus 1 by 6 raised to the power 1 plus 1 by 6 raised to the power 2 plus 1 by 6 raised to the power 3. Similarly, it will go on. Now, if you look at here, this is a GP series. And for a GP infinite series, my formula will be A upon 1 minus R. Correct? So this will be 5 by 6, 1 upon 1 minus 1 by 6. Correct? Yes or no?
Yes.
Yes, ma'am.
Okay. Now, if you solve this, you will get 5 by 6
1.
into 6 by 5, which is 1. So I'm getting sum as 1. So this is a valid EM. Is the solution clear?
Yes, ma'am.
Yes, ma'am.
Everyone,
Yes, ma'am.
shall we move forward then?
Yes, ma'am.
Okay. Now, probability mass function of a random variable is given by this. Find the value of k.
Ma'am, 2.
2. What about others?
K is
0.2, ma'am.
0.2.
0.2, ma'am.
Yeah,
Zero
K
point
is
two.
0.2.
0.2.
0.2. Correct. So how did you guys solve it?
We just added all the outcomes.
K
So
plus
this is what?
0.4 plus 2k is equal to 1.
Yeah, so probability of x equals to 0 is k, and probability of x equals to 1 is 0.4 plus 2k. So using the properties of probability, which is the sum of all the probabilities equals to 1, right? So this will be what? K plus 0.4 plus 0.2k will be equal to 1. If you solve this, the value of k is coming out to be 0.2.
It's 2K.
Okay?
Ma'am, it's actually 2K. You wrote 0.2K.
Oh, sorry. Right?
Yes, ma'am.
Okay. Now, next question. A random variable x has the following probability function. What is the value of probability of x less than 6? Solve it and tell me.
No, ma'am.
Hello?
Yeah, it's 0.81, the first
What,
one.
what about others?
Yeah,
Yes,
for the
ma'am.
second one, we should find for x equals to 1, 2, 3, and 4, right?
0 to 5. 1, 2, 3, 4. Correct.
So it will be 0.8.
It will be 0.
Yes, ma'am.
0.81 for first question.
Huh. Okay. So what is the value of k you are getting?
0.1.
0 point. Okay. So then you have to, for probability x less than 6, this will be probability of x equals to 0 to probability x equals to
5.
5. Now probability of x going from 0 to 5. This will include probability of x equals to 1 to probabilities of x equals to
4.
4. Is the question clear?
Yes,
Everybody
ma'am.
are
Yes, ma'am.
everyone is able to solve it, right?
And how to find the k value?
How to find the k value? Okay. These are my PMF, right?
Yes, ma'am.
Okay. So what is the second property of a PMF?
मैम सम करके सबको 1 के इक्वल कर देंगे ओके का वैल्यू आ जाएगा
So we know that the sum of all the probabilities are equal to 1, right? So if you
हाँ
sum all the
PF
Yes.
values,
बराबर
sum of all the sum, like if you sum all of these values and equate it equal to 1, you will get the value of k. Fine?
Yes, ma'am.
Okay. So you have not solved this question then?
Yes, ma'am. Solve.
Okay. Shall we move forward then?
Yes, ma'am.
Yes, ma'am.
Okay. Solve this. Naman has to give 3 mock tests. The probability that he will not give any mock is 1/8. The probability that he will give 1, 2, and 3 mock tests are 3 by 8, 3 by 8, 1 by 8. Let x be a random variable which represents the number of mock tests given by Naman. What is the probability that he will give at least 2 mock tests? Solve it and tell me.
Ma'am, 0.5.
Ma'am, 0.857. Technically
Ma'am, 0.5.
0.86.
So, okay, what are my values that x can take? What are the values?
X बराबर 2
0,
और
1, 2, 3.
1. And what are the probabilities associated with it?
1 by 8, 3 by 8, 3 by 8, 1 by 8.
Now, what we need to find out probability of x?
He has given at least 2 mock tests.
So, x, what we need to find out?
Less than equal
Greater
to
than
2.
greater than equal to 2.
Greater than equal to 2. So, this is what? Probability of x equals to 2 plus probability of x equals to 3, right? So, just add both of them.
0.5.
1 by
Yes,
8,
ma'am,
which is
it's
4
coming
by 8,
0.5.
1 by 2, 0.5. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
But
before you said 0.85 something.
no, it's 0.5.
Yeah, I said that. My bad. I did some calculating error.
Oh, I just because same answer also I just get because I just thought less than at least 1.
Yeah, that logic which we used, it's a wrong logic. I just now realized because it's
7 by
deducting all
8.
the it's deducting the possibility that all of the 3 quizzes have been attempted.
Is the confusion clear?
Yes, ma'am.
Right. Now, table 8.1 gives the probability distribution of a discrete random variable x. Find the probability that x takes a value less than 3.
Mm-hmm. 0.51.
0. What about others?
Yes, ma'am. 0.51.
0.51.
0.5.
0.5.
So we need to calculate the probability that x takes less than 1. So probability of x less than 3 is what? Probability of x equals to 0 till probability x equals to 2. Just add all of them and you will get 0.5 back, right?
Yes, ma'am.
Now, 3 cards are drawn in succession from a deck with replacement. Find the cumulative distribution function for the number of red cards. You need to find out cumulative distribution function.
Ma'am, I didn't get how to solve this.
Okay. So what is it stating that
It's
3
1
cards
by 2.
Huh? you have to calculate the cumulative distribution function. So it will be like function of a something, the numbers. Okay, how I will just solve. Okay, so what is the situation? 3 cards are drawn in succession from a deck with replacement. Okay, we are drawing out 3 cards. Find the cumulative distribution function for the number of cards. Okay, now, so we are taking out 3 cards. So I am denoting red card with R, and we are having one, let's suppose red cards, then we have black cards, correct? Black and red, right? So I'm having one, like I'm denoting red card with R and black card with blue. Okay. Now I'm taking out 3 cards. So I can have different type of situations, right? So first of all, I
Yes.
can have the first card as red, the first, second card as red, and the third card as red. Okay. Can you tell me how many total outcomes, like how many number of samples will be there?
Combinations.
It will be 8, right? So 2 raised to the power 3, which is 8, correct? So I will be having 8 sample space. So the first sample space is all the 3 cards are my red. Now I can have a situation in which the first card is red, the second card is red, and the third is black. Yes? I can
Yes.
have,
Yes.
then I can have R, B, R. Okay.
Yes.
Then I can have R, B, B. R, B, B. I can have B, R, R. Then I can have B, R, B. B.
PBR.
So I can have these type of uh, sample. Okay. Now, so I am denoting X as the number of red cards. So what are the values that X can take? It can take 0, 1, 2, and 3. Correct? Yes or no?
Yes, ma'am.
Okay. Now, what are the probabilities associated with it? So X is 0. That means the situation. Correct?
Yes.
1 by
So
8.
this will be 1 by 8. Yes
Yes.
or no?
Yes.
Yes,
Okay.
ma'am.
Now, for 1, it will be?
3 by 8.
It will be 3 by 8. For this, it will be?
3 by 8.
And for 3?
1 by 8.
1 by 8. Correct?
Yes,
Now
ma'am.
you have the PMF. Can you calculate the CDF? How will you calculate? So my FA would be what? So first of all, my value of A is less than 0.
Yes, ma'am.
Then, okay, let's write down all the range. Okay. First of all, my A is going from A is taking values less than 0. Then I can have 0 to 1. Then I can have 1 to 2. Then I can have 2 to 3. Then I can have greater than equal to 3. Correct?
Yes, ma'am.
Okay. Now tell me the values. For A less than 0, it will be
0.
0. From 0 to 1.
0.125.
Huh?
Yeah, he's
And
actually
how
correct.
this
1 by
comes 1
8.
by 8, 3 by 8.
1 by 8. Then this will be
3 by 8.
3 by 8.
Yeah.
No, 1 by 2.
1 by 2.
Will be 1 by 2.
Why?
So
Yes,
this is
ma'am.
what? Probability of
How, ma'am?
A less than 2. So it will be adding what? Probability of X equals to 0 plus probability of X equals to 1.
But ma'am, it's written 1 less than equal to A.
Huh.
So it will only have like probability of 1, right? Why will it have? Oh, okay. Wait, no, no. No, the boundary is at 1. It's not going till 0.
You make a graph. This is okay. So less than 0, it is 0. Correct?
Yes,
Now
ma'am.
at 0, it is it jumps till 1 by 8. Correct? Now from 0 to 1, it is 1 by 8 only.
Yes,
Correct?
ma'am.
Now at 1, it will again jump. Right? So at 1, what will it be? This 1 by 8 plus this
4
1
by
by,
8.
sorry, 3 by 8. So 3 by 8 plus 1 by 8?
4 by 8.
4 by 8. So this will be what? 4 by 8?
1 by, yes.
1 by 2? Now
Yes,
from
yes.
till 1 to 2, this will be 1 by 2 only.
Yes, ma'am.
Now at 2, it will again jump to
7 by 8.
7 by 8. So this
Yes,
is
yes.
7 by 8. Okay. Now till this is 3. So till 3, it will be 7 by 8. Now again at 3, it will jump to 1.
1.
So from greater than 3, it will be 1 only. Got the point?
Yes, ma'am. Yes.
Huh. So this will be 7 by 8 and this will be 1. Now is it clear how to calculate the CDF?
Yes, ma'am. Yes, ma'am.
CDF is cumulative. So you have to add all the numbers. That's it. Just remember that. So if you see here, this from
Ma'am,
0 to 1. So this is calculating equal to 0 and less than 1. Now at 1, it will jump. So 1. So this range is what? This thing. What is this thing? This is this range. Now you got the point?
Yes, ma'am. Yes, ma'am.
Okay. What about others who are finding difficult for the CDF thing? Now is it clear?
Understood,
yes,
ma'am.
ma'am. Now it's clear.
Now it's clear? Okay.
Ma'am, it's clear, but ma'am, can you tell like what is the application of its use? Why it is used?
Ma'am,
It's like
answer
a
to ma'am.
function. It's like a function on a graph.
CDF you're asking. Like if we like CDF is okay. So like till now we were calculating if you want to CDF is when we use CDF when if you want to calculate the probability of less than or greater than something. Not at that particular point, but less than that point or greater than that point. Then only CDF comes. Okay. We have just named it as CDF. So what is PMF? PMF is probability at that particular point. That is called PMF. Then what is CDF? CDF is if we have to calculate the probability less than equal to something, then that probability is known as CDF. Got the point? We have just named it. Okay.
Okay. Okay.
Ma'am, how do all we get answer using this?
How what?
Means what's the answer?
What's the
Previous question, answer of the previous question.
previous? This one.
No, no, no. Question number 8.
Hmm. What about question number 8?
What is the answer?
Answer is this CDF.
Oh, we all have to draw the CDF only.
Like in the exam, you will be getting like option wise, like MCQ.
Oh, like it will ask what range
Like
will
you will
be
be having
from
4
1 to
options.
2.
You will be having
Ma'am,
4 options.
CDF 3 draws now.
Huh?
CDF rate cards 3 draws. This question. CDF.
Huh. What about this?
CDF number of cards 3 draws. 1/8 or 3.
Ma'am, what if they ask without replacement? What will be the answer?
Three
With
cards are
replacement, I
drawn
guess.
without replacement. Then
Yeah.
that will be a different condition. For that, see,
Ma'am, if in this case they just given with replacement means we know totally how much cards it will be there red. But if in this without replacement means we can't find out how many what is the probability count they are taking for the first time, for the second
that's
time,
what.
like that.
So like get the question like in the exam, you would be given a situation in which you can calculate the probabilities. Okay. So first of all, if you have to calculate the CDF, first you have to know what is the probabilities, correct? Yeah. So it will be simple, like 3 cards are drawn in succession with replacement. So with replacement only, we can have these kind of conditions, right? So we are replacing it. That's why we are having RR, then RBR, correct?
Yes, ma'am.
Okay, then I guess we have last. Yeah, this is okay. So this problem is clear.
Yes, ma'am.
Okay. So CDF part is clear, I guess, with this question, right? No doubt.
No doubt.
Okay. Now, last question. From a vessel containing 4 black and 5 white balls, 4 balls are transferred into an empty vessel. Let Y be a random variable that represents the number of black balls which are transferred. What value of random variable will have maximum probability? Everybody got the question?
Yes, ma'am, a vessel contains, let's keep a vessel V1 contains 4 black balls and 5 white balls, ma'am. From that, we are just taking randomly 4 balls. It can be, we didn't know what's the color of the 4 balls, and we are just putting into an empty vessel. They're asking that what is the maximum probability that black balls can be there. Then I think the 0 probability means 0. For 1 probability, we get 4/9. For 2, 3/9. For
Okay, first of
3,
all, tell me, we need to find out the value of random variable, what value of random variable will have maximum probability. So X is a random variable which is denoting the number of black balls transferred, correct?
Yes, ma'am. I
Ma'am,
think 3 black
it's
balls
Y.
transferred will have the maximum probability.
Okay. So now, what are the values that X can take? It can take 0.
1, 2, 3, 4.
Okay. Now, so it is asking what value of random variable will have maximum probability. So first of all, you have to calculate probability of X equals to 0. Then X equals to 1, X equals to 2, X equals to 3, and X equals to 4. And compare which value is having the highest probabilities. Now you got the point?
4/9, as I think it has highest probability. Means first ball.
4/9.
I mean X is equal to 1.
Actually, I think it's 2
X is
and
equal
3
to 1.
both. Because at 2 we will have 4C2, that is also 4. And at 3 we will have 4C3, that is also 4.
I think it's X is equal to 1, ma'am, because while we are taking the first ball, there is a chance that 4 probabilities out of 9. While we are just taking second, third, and fourth, the probability count is getting lesser.
Okay.
Ma'am, we have like a total of 4 balls is taken. So
My
when
bad.
one, So a total of 4 balls is taken. So when 0 black balls are taken, 4 white balls are taken, right? So like the probability of x is equal to 0 will be 4c0 into 5c4 by the whole divided by 9c4.
Correct. Very good. Similarly, probability of x equals to 1 will be?
So x equal
4C1,
to
5C3, and 9C4.
4 into 5c3.
So this will be 4c1 into 5c3 divided by 9c4. You have to
9C4.
calculate all the probabilities like this. Now you got the point?
Yes, ma'am. I think it's at x equals to 2.
Sorry?
Yes. The maximum probability,
Hmm.
the value is x equals to 2.
What about others? Are you guys solving it?
Yes, ma'am,
Yes,
just
ma'am.
keep
Yes,
on.
ma'am. Solved.
You have solved. What about others?
Actually, I want to finish this fast and go to my marks.
Have you finished it?
Yeah, I have finished this one. X equals to 2.
Okay, okay. If you have finished, you can go. It's fine. Because this is the last question.
Oh, okay.
Yeah. You have understood the concept and everything, right?
Yes, ma'am.
Okay.
X equal to 2, we have maximum.
Yeah, x equals to 2. So the answer is x equals to 2. Everybody is getting that answer?
Yes, ma'am.
Good. Okay. So this was the last question. So I hope like week 9 is overall clear. What is PMF? What is a random variable? What is a CDF? These three things. Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Ma'am, if we have further doubts, then we can clear in another session.
You can clear, and I think we have 30 minutes, I guess. Yeah. You can clear.
Not now. Today I'm gonna study once more, and
Okay, sure.
I would like to ask in the next session.
Uh-huh.
Tomorrow is the session.
Not tomorrow, Friday.
And Friday dot session, right?
Friday 8 to 10. Sorry?
Friday
Given my
dot session.
Yeah,
Week
Friday
9.
is a doubt session. Correct.
Okay, ma'am.
Okay, so you guys just go through the content once again. Go through. I'll just upload this
Ma'am,
PDF.
can
Go through
you
this
teach
PDF
me
and all.
CMF for once again?
CDF.
Means CMF.
CMF.
And can you please solve
Sorry,
this
CDF.
question?
Sorry, CDF.
CDF.
Just a summary, ma'am, because.
With this example, I can go, right?
Yes, ma'am, it's okay.
Okay. So CDF is what? CDF is a cumulative distribution function. Cumulative in the sense we are adding the probabilities, right? So like this is the PMF that I have been given. X equals to X is taking 0, 1, 2, 3, and these are my probabilities. So now, okay. So main thing is if you need to find out this thing, now just make a graph. Okay. The easiest thing is just first make a graph. So we will make a graph, x-axis 0, 1, 2, 3, and here are the probabilities. Okay. Now, so we are talking about CDF. CDF in the sense, the cumulative thing. We are adding the probabilities. So first of all, this is 0. So less than 0, it will be? The probability is less than 0.
Will be 0.
It will be 0. So this part is 0. So now next, at 0, we know that probability at 0 is 1 by 8. So it will jump at 1 by 8, correct?
Yes, ma'am.
Okay. Now from this till 1, it will have only probability 1 by 8. Okay.
Yes, ma'am.
Now at 1, again it will jump. Okay. So at 1, at what point it will jump? So this is 1 by
Again,
8.
it jumps at 1 by 2.
3 by 8. So this will be 1 by 2. Correct? Now, from
Yes,
1
ma'am.
to 2, this will be 1 by 2 only.
Yes, ma'am. It's 1 by 2.
Then at 2, it will again jump at 7 by 8. Then from 2 to 3, it will be 7 by 8. And again at 3, it will jump at 1. Then it will be constant. Okay?
Yes, ma'am.
Yeah, this is just a serial. So just write down all the values then. So A is taking, so A is my value less than 0, it will be 0. Then from 0 to 1, it will be 1 by. Then from 1 to 2, it is 1 by 2. Then from 2 to 3, it is 7 by 8. And from greater than 3, it will be 1. Just from the graph only, we calculated this value. Fine?
Yes, ma'am. Ma'am, can you tell me what is the use of this? You just said, but I can't understand.
No, CEDF, okay. So we were talking about probability of x equals to 0. We are talking about probability of x equals to 1, right? So what is this? This is my PMF, right? Probability mass function.
Yes, ma'am.
We are just, these are my probabilities at a particular point. If I have to calculate the probability at x less than equal to 1, or probability of x less than 1, probability of x less than 2, something like that. Not a particular value, not the probabilities at a particular value, but the cumulative of some probabilities. So that's why we say it's a cumulative distribution. We have just named that probability. It's a cumulative distribution function. This is a probability mass function. Okay?
Yes, ma'am.
Hmm.
Now I got it.
Okay. Varun?
Ma'am,
I
I've
have I
posted my
have
doubts.
I have also
Just
posted the quiz two doubts in chat
quiz two
box.
doubts. Okay,
Yeah.
okay. I'll just solve that
Yeah,
one.
the last question is I told him it's 1 by 2 into 3 by 7. It's because like at first either of the four students will be picked. So it's like 1 by 2. And then one student is getting reduced from the prime part. So now three students remain from the prime part. And one student is also getting reduced from the total number of students. So it will be 3 by 7 and hence same goes for the rest. I also made a mistake in this question.
This one, in a quiz competition, 8 students.
Yeah, this one I also
Yes,
posted
ma'am.
another one.
Posted on another one.
About a company has 15 offices. That question.
Okay. So what's your doubt in this?
Which question you're asking, ma'am?
Quiz competition one.
Yeah, I cannot understand the questions of. Can you explain?
In a quiz, 8 students are competing, each assigned a roll number from 1 to 8. What is the probability that only students with prime numbered roll numbers secure the top 4 ranks in any order? Enter the answer correct to 3 decimal places. Probability that only students with prime numbered roll numbers secure the top 4 ranks in any order. So first of all, we need to choose four students from Okay.
Ma'am, here in this question, we can arrange 4 students in 4 factorial ways, right?
No, it's written in any order.
Yeah, any order means we can arrange any 4 in
No,
4
So
different
first
it's
of
ways.
all,
written
we
that
need to find out the probability that all the prime numbers are arranged in like they got the first 4 ranks, correct? 2, 3, 5, 7. These are the numbers. Okay. So first of all, the total number of ways I can arrange I can arrange the 4 ranks to any 4 students. How can I do that? I can do that in
1 by
84 ways.
2.
Yeah. Yes.
Okay. Now, my favorable outcome is what? That I have to arrange these only prime numbers, right? So I have only four numbers, 2, 3, 5, and 7. Now, I have 4 places. Now, I can do this in 4. So the first rank will be given to only any of the 4 members, correct? Now,
Yes,
then the second rank will be given to the 3, then 2 and 1, correct?
yes, ma'am.
Okay, so this will be 4 factorial. Now, the total the probability will be what? 4 factorial divided by 8p4, correct?
Yes,
So
ma'am.
when you solve this, you will get the
Yeah,
answer.
yeah.
Okay.
Also, I have posted another question about the company has 15 offices. Question I have posted.
Ma'am, I want to ask that in the extra activity 3, in the central tendency part, do we also have to mention the value of like the mean, median, and all those, or we have to just say that it is applicable or not?
I think you have to you have to describe the data, right?
Yeah, we have to
Yeah.
like
Yeah, you
give
have to write the
one
number.
table
Means the value of the mean,
in
median, mode we have to write.
in the main sheet. It's given in the sample, the example which is given.
And the value of range, variance, standard deviation, all those,
Yeah.
all those we have to write in that sheet with the reason.
Yeah, it's if you see the extra activity 3, there's a sample sheet given. If you click
Yeah,
on it, then you can see that it leads to some activity 3. And
yeah.
the first cell, A1, there's one link of the spreadsheet with which the data came. So if you click on that spreadsheet and check on the individual subsheets, you will can find that there is mentioned mean, median, mode, and like measures of central tendency as well as measures of dispersion with the value and interpretation.
Okay. And one more question. There was that visualization thing in the center tendency part. So what is the visualization thing? Means we have to draw graphs of each variable.
Correct. You can if you have to show visualization about your data or something about like central tendency and everything, how you will show it? How you will visualize it? By making
Means
graph.
the visualization part was only in the center tendency, not the dispersion.
Yeah.
Ma'am, we have already made the graphs, right?
Yeah,
In activity
that is only I'm
2.1.
asking. That was part of activity 2, right? Visualization also.
Okay. Varun is here, right?
Yeah, yes.
Yeah. So, what was the question? The question was 15. What was that?
No, I have posted again.
Offices and wants to set up a two-way communication. Okay. So I'm having in total 15 offices and I had to make a two-way communication channel, correct? So the question they have been asked is, how many communication channels are needed in total? How many communication channel? So one company is here, one company is here. I can have one channel, right? So for one channel, I need two people, two companies, correct? So in total, I'm having 15 companies. If I have to make a channel, so it will be, I will be choosing for 15, I will be choosing two companies, correct?
Yes.
Okay. And the one condition here is say that the three small offices will not have direct communication with one another, right? So I will subtract it. I will subtract 3C2. Three companies will not have the direct like connections, correct? So if you calculate this value, you will get your answer like that.
Okay.
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 Hmm. Is it clear now?
So, ma'am, I have posted a similar doubt.
You have posted a similar doubt.
There are 15 train stops. The second last image in the chat box.
There are 15 train stops between Chennai and Assam. How many train tickets are to be printed so that a person can travel between any two stations, irrespective of direction of travel? So here, irrespective of direction of travel, in the sense like what is your direction of travel? You have to take a ticket. So for every travel, for every destination from Chennai to Assam. Okay. So like Chennai and Assam. So you don't know which direction you are traveling. So if you're going from Chennai towards Assam, there are many stations in between, right? 15 train stops. In total, I am having 15, 16, 17 stops are there, right? So I need to take tickets for all of, like if I'm going from one direction, I have to take that direction. If I'm going from other direction, I have to take that ticket as well. So irrespective of direction of travel, in the sense, irrespective of which direction you are traveling, you have to take a ticket. Got the point?
Oh, okay. Yes, ma'am. Got it.
Okay.
Ma'am, I've posted another doubt. Two more doubts actually. Wait, this question is kind of incomplete. So I posted one question 4.
Where
It's
is it?
kind of incomplete. It's a like a continuation of another question. Let me send that as well.
Okay.
All these are from week 9.1.
Which one? Okay. Week 9.1. I can just open activity. Week 9, activity 9.1, na?
Yeah, yeah, activity 9.
Which question?
Question 3. Question 2 and 3 are like related.
Two cards are drawn simultaneously from this one, right? Two cards are drawn
Yeah, yeah, yeah.
simultaneously from a well-shuffled deck of 52 playing cards. Each of the face card carries 10 points. Okay. And the other cards carry the same point as its number. Let X be defined as the sum of the points of the withdrawn cards. Acha.
Yeah, so I have a doubt in number 4.
Okay. How many outcome will result in X equals to 19?
So there are 12 face cards. So it will be 12, and I know that there are 4 cards with 9. So it will be 12 into 4, 48, but they are given 64.
Just a second. So I need X equals to 19, right? So what are the possible ways I can have? Like it can be 10. Sum of the cards should be 9, right? Sum of the points of the withdrawn cards. Okay. You can have 10 to 10 on. So face cards. 9. 4. 10. 18 plus 1 as well. 18. Because it is 10. How many outcomes we receive?
And can you see that the minimum sum of the cards starts with 2, right?
Yeah.
So can range from 2 to 20.
Yeah, the range will be 2 to 20. Those cards. That will be 10 plus 9. It will be 1 card. That is okay now. Oh, okay. The face cards are 10. Also, I'm having 10 numbers, right? So this will be 4. So in total, I'm having 16 cards for 10 points. And for 9 points, I'm having 4 cards. So it will be 64. Yeah, it is 64. You got the point?
We
See.
have to consider the 10 points also. Yeah, I get it. I get.
Yeah.
I didn't consider those.
That we forgot.
I
Okay.
remember next question, number 5.
I have a request in between.
Yes.
The session what Professor Usha Mohan taught us on the day, she actually told that it will be shared in the supplementary, the slides, but we don't see it in the supplementary material till now.
Which one?
The
The revision session.
Yeah,
Oh, okay. I think it has not been uploaded. Yeah, I'll see to it.
please. Thank you.
Yeah.
Ma'am, the previous question we were solving, can you please explain? I was confused in that too.
Which one? Previous, which one?
Do
The
you mean
question that
the
the
x equals to 19?
X equals to 19 you're talking about?
Yes, ma'am.
Okay. So we are having, see, they are talking about x equals to 19, right? So the thing is, all my face card equals to 10 points, right? And all my number card are equal to the points that like equal to the numbers they are having. So if I'm having 2, the point is 2. If it's 3, it's 3, correct? So they are asking x equals to 19. So what are the possible ways I can have 19? It can be 10 plus 9, correct? So now, what are the cards which are having 10 points? All the face cards?
It's 12, yeah.
And the number card 10. So all the face cards are 12 and the number card 10 is 4. So 4 plus 12, 16. And 9 points are the 9 numbered cards. And they are all 4. So in total, I would be having 16 into 4, 64. Okay? Is it fine?
The answer says 48, right? Or 64?
64.
The correct answer is 68, 64.
64, 64.
Okay. The next question was?
The very next one, number 5, I guess. Yeah,
Random
number 5.
defined as the time from now until the next rain occurs. It can be 0 to infinite only.
No, but 0 to infinite consists of real numbers. Like 1.2.
Yeah, it's a continuous, no?
But in brackets is written in hours.
In hours, yes.
So it's
I can
not.
have 1 hour, 2 hour, 3 hour, 4 hour.
Yeah, so it should be
Is it
natural
related
number.
to the uncertainty of the rain? Is it related to the uncertainty of the rain stopping, or it's related to the continuous?
Defined as it's a continuous, right? From now until the next rain occurs. So it like the time, like after what time the next rain will occur. So it can occur at 1.5 hours later than that, or 2.5 hours, or 3 hours, 4 hours, 10 hours, right?
So how will we know whether the variable is continuous or discrete?
See, the time is in hours. It's a measurement.
Yeah, but in brackets it's written in hours, so I would assume that it's discrete, no?
In hours. So there is no particular, see, discrete is like you can count things. It's countable. So here it is asking only X is defined as the time in hours from now until the next rain occurs, right? So we don't know when it will occur. So I can have 1.5 hours. I can have 1.2 hours. I can have 1.3, 1.5, 2, 2.5, 2.2, any hours, right? I can have any numbers. So in
Yes.
particular, I cannot say only 1, 2, 3. That's it. No, right? I can have any numbers. In between 1 and 2 hours also I can have the rain, right? In any hours, correct?
Yes.
That's why it's a continuous. Just
But
remember
then I
that if there
can.
are measurement, if there is a measurement including any measurements or something, that's a continuous. Okay?
Then what about age? Like suppose let's define a random variable x is defined in years, uh, the age of a person. So I can't just say he's 3.9 years old.
So age is like continuous. So like years in the sense,
No, age is
3
discrete,
years,
right?
2.5 years, huh?
Age is discrete.
Age is just age is discrete.
Yeah, in the first lectures we were taught age is discrete. The age of a person.
Uh, yeah, I'll just think about it. I'm
No,
having a
and what if you replace the in hours part with seconds?
yeah, then also it's a continuous.
No, the age of person is always a continuous. It's not a discrete variable, if I'm right.
What's your name, sir? Sridhar, right? What's your age?
Yeah. So I'm 35.
So did you say that you're 35, right? So did you just say that I'm 35.9 years old, 35.6 years old, like that? You said you're 35 years old, right? So how is it continuous? Continuous is when you like have a decimal point, right? You didn't add a decimal.
See, even though we say in a normal way, when you ask about it, we talk about whole number. But when you're talking about, for example, when somebody is asking, let's say that there are some kinds of application which talks about you put your number of age, and in the below the column they will say your years and months and days. So there it becomes continuous, am I right?
Yeah, at that time it becomes continuous. But when it's specifically telling you years or specifically it's telling you hours.
I mean, when you are talking in the very, what do you call, informal way, maybe, because when it comes for the mathematical or statistical point of view, it's a continuous one. But what we are talking about is a regular, what do you call, addressing the age. From the statistical point of view, I feel it's a continuous one, variable.
Yeah, I agree with you on that. But when we like had the activities, there was someone who had this age column and she just put age as discrete. And even in the like lectures also, age was considered as discrete, not continuous.
Then it becomes two aspects. The age is discrete as well as continuous in this case.
Yeah, then that is the confusion, right? How can I know age is what where? I have to like have a solid
when you say
conclusion.
when I say it's 25, 35, the thing 45, then it's a discrete one.
Yeah,
When I'm
it's like
talking in
if you're
terms of
taking just a whole number, right? So if it's like 1 year, 2 years or something, then you can take it as a discrete. But if you're taking it's like months, days, and something like that, then it's a continuous thing. Like you can just remember it like that. Yeah.
Okay.
Hmm. Okay. Anything else?
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt in activity 3.
9.3.
Extra activity 3.
What's your doubt?
Ma'am, in the sample spreadsheet, the scatter plot is it is linear. And when I have made my plot, then that is scattered. What should I do then?
Once again, what?
Ma'am, in the sample spreadsheet,
Uh,
where the scatter plot is drawn, it is type
yeah.
of linear, it is showing some relation. But when I have drawn for my data set, it is all scattered.
Yeah, but no, that means there is no relation, I guess.
Yes, ma'am. So should I show this that there is no relation?
You can say that.
Okay.
No, like there is a relation. Anything.
Ma'am, this is same for the categorical variable as well for my data set.
Achha. Just write the things that you're getting. That's it.
Okay. Thank you.
Okay, then it's yeah, it's about time. So any other doubts?
thank you. Kindly arrange for that slides to be uploaded.
Slides, I will just check on it. Yeah.
Okay. And when can we expect the result for the quiz 2?
Oh, by this week, I guess.
Okay, okay.
By
Because
this week.
already the answer key is out, and
So
they
just wait for me.
this time they sent 2 feedback form. What is that to do with?
Sorry, what?
Any idea? This time in the mail they have sent a link for 2 types of form for the feedback. One is asking about the regular feedback, other is to do that. Is it mandatory to fill both the forms?
Yeah, so yeah, you can fill both of the forms. So the first form that we like it has been sent by you can fill both of the forms. It's fine.
Okay.
So the first one is like it is sent by us, like the instructors. So we need to know something. And the other is
Okay.
for like if there is any error, like if we are the thing is like if we have to check whether the questions are correct or not.
And was there any error in the questions this time?
There was in CT, right? There was a like for a single correct question, there were 2 options correct.
Which one?
In CT.
Oh,
No,
see,
but
see, that's
I
the
think
see, we are just checking for the stats only. So that form is for stats.
only for stats.
Yeah, not for CT is they will just from the CT people they will give you the form. So you have to fill that.
Okay, thank you.
Okay. Okay then. Bye everyone.
Good night. Bye.
Yeah. Bye.
Bye, ma'am. Thank you, ma'am.
Thank you everyone. Good night.